In this video, I'd like to talk about the math question of the day for Tuesday, June 20th, 2023. And with this example problem, we have that Lucia is using energy at a rate of 420 kilocalories per hour ice skating. At what rate is Lucia using energy in calories per minute? So we have this rate conversion type of problem here. And problems like these are often taught in grade school, but you might see this in an Algebra 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And with rate conversion, it's helpful to write out first what we have as a ratio, and then we can essentially set up this rate conversion as a multiplication problem, specifically multiplying by fractions, so that we can change the units. We are told that Lucia is using energy at a rate of 420 kilocalories, or kcal, per hour ice skating. So per means division, or divide by. We have kilocalories divided by hours. So let's write that out. 400 kilocalories divided by 1 hour, since it's just per hour. So we can write 1 hour down below. And we need to convert this to calories per minute. So that's our goal. Let's write that down. We're looking for calories per minute. Now, in our numerator, we have kilocalories. So to convert that to calories, we need to know their relationship. So we can write down what we know here. We know that in 1 kilocalorie, or 1 kcal, there are 1,000 calories. And you might ask, how do we know that? Well, kilo is the root word in the metric system for 1,000. So 1 kilocalorie just literally means 1,000 calories. And we also need to convert between hours and minutes. And we know that there are 60 minutes in 1 hour. So we have these relationships. We can set these up as ratios. For instance, let's first change hours to minutes, and to do that we will multiply by this ratio. We will divide one by the other. Since 60 minutes divided by 1 hour, since those are really the same thing, that's just equal to 1. And we can always multiply by 1 without changing anything. It just comes down to whether or not we put hours on top or in the bottom. And since we want to cancel hours out, and it's in the denominator here, we want to put hours in the numerator here. That way we have hours divided by hours, and something divided by itself will cancel out, since that's just 1. So we put 1 hour up top, and we put 60 minutes down below. And again, since these are equivalent, 1 hour and 60 minutes, we are dividing something by itself, which is 1, and we can always multiply by 1 without changing the number. So this way we can cancel out hours. And if we multiplied straight across, if we multiply these fractions, we would end up with the units of kilocalories per minute, which is almost what we want, but we want calories per minute. So let's also multiply by this next relationship. And again, we just need to determine, do we put kcal up top or down below? And since it's currently in the numerator and we want to cancel it, we want to put it in our denominator. And that way we have kilocalories divided by kilocalories, which of course is 1, and they will cancel each other out. And we'll put our 1,000 calories up top, and we can see these units will now cancel. And notice we end up with calories up top and minutes down below, which is our goal. That's exactly what we want. And once we set up this multiplication with fractions so that we get our units right, we can then just multiply straight across. we have 420 multiplied by 1,000. So we'll just add 3 zeros to the end of that. And our unit up top will be calories. And in our denominator, we just have 60 multiplied by 1 multiplied by 1. So that is just 60. And our unit down below is minutes. Now we can simplify a little bit further. We can cancel out a 0 in each. And 6 goes into 42,000 7 times. So we have 7,000 calories per minute. And this right here should be our final answer.